Morning guys! Today we're going to take a look at a few examples of how to apply the kind of like angle theorems and their converses in the context of two-column proofs. So we're going to start off on page 10 of the Unit 4 Classwork packet. Once again, page 10 of the Unit 4 Classwork packet. And we're going to take a look first at example number 3. Okay? Now, example number 3, here's one piece of advice I'm going to give you guys, okay? Always write the information that they give you in the diagram. What do I mean by that? In this problem, they tell us that angle 1 is congruent to angle 7, right? So what that means is I'm actually going to draw tick marks, or in this case, arcs for angle 1 and angle 7. That's just to help me visualize which angles are in fact congruent, and that's going to help me fill in my my statements and reasons later on. Okay? All right. Now, statements on the left, reasons on the right. Right? No pun intended. Now, notice something. The nice thing about this proof is that because it's so short, it's actually almost all filled in for us already. What do I mean by that? Well, we always start with our given, right? So guess what? There's your given. Then we always end with what we're trying to prove. So down here, as my last step, I'm going to have that angle 4 is congruent to angle 8. Right? So now, look at that. I filled in 3 of the 6. Now I just basically have 1.5 steps left. Isn't that awesome? Okay, now here's the thing. Notice that they told me these two angles are congruent, right? What kind of angles are those? I wonder. Those are, in fact, alternate exterior angles, okay? So what I would say then is that because alternate exterior angles are congruent, let me say that again. Because alternate exterior angles are congruent, that means that the lines are parallel. Let me show what that looks like in a proof. On the right-hand side, for the reason, I would have converse of alternate exterior angles. The reason it's converse is because what I'm using it to show is that these two lines, which are called L and M, so L, remember I used the two vertical kind of like L things for parallel, L is parallel to M. Now, because I know that these are parallel lines, what type of angles are these? Well, let's take a look. 4 and 8 are both on the left side of the transversal, and they're both below their lines. In other words, we would say, that they're on in the same relative position, and that means that they are corresponding. So my last step would be corresponding angles postulate. Okay, so something that always gets a lot of people kind of confused. Why did I use converse here and not here? Well, this step, I was trying to prove that lines are parallel, right? If I'm trying to prove that lines are parallel, that's when I use the converse. But for my last step, I'm not proving lines are parallel anymore. I've already done that in step 2. Now, I'm trying to prove angles are congruent. So to prove angles congruent, I use the regular theorem instead, okay? If this file sounds like a bunch of mumbo-jumbo to you, don't worry too much, okay? This is kind of one of those, like, what is this kind of topics, okay? Well, let's try another example, all right, just to kind of make it sink in. And then what we're going to take a look at next is example number 5. Alrighty? All right, so, oh my gosh, it's like the mutant tic-tac-toe board again. Oh my god, why? Spare me, right? Yes, of course. All right, and let me just do some labeling here. I don't know how they chose these numbers. 1, 2, 3, 4, 5, 6, 7. Did I label that right? Oh no! Oh no! See, this makes no sense. 4, 5, 6, and 7. And this is line A, line B, line C, line D. Okay, so first things first, guys, I would always write the information that they give me in the diagram. So in this case, they actually have 2 givens. That's actually really nice because that's going to take up 2 full lines in our proof, but we'll talk about that in a second. Okay, so they tell me C is parallel to D. So the way I'm going to show that in my diagram is I'm going to draw 2 arrows. That's pretty simple, right? Then they also tell me something about angles 1 and 7, okay? They tell me they're congruent, so I'm going to show that by using these tick marks right here, okay? All right, let's start filling in, okay? All right, so for my proof, as you'll recall, 2 columns, the statements on the left, reasons on the right. Take a look at how many givens I have. How many pieces of information did they give me? 2. So guess how many lines it's going to take up? 2. All right. So again, a lot of this is actually much easier than you might give it credit for. All right. So I have 2 givens, and I'm just going to space them out on these lines. So C is parallel to D, and I'd say that angle 1 is congruent to angle 7. So far, so good. Okay, now they give me another piece of information here. They make a claim. Angle 3 is congruent to angle 1. Okay, well guys, how do I know that? How do I know that? Just looking at this diagram. Well, I have 2 parallel lines. That's good. That lets me say some things about angle types. And what kind of angles are these 2? They're both on the right-hand side of this transversal, and they're both above their lines. What type of angles are those? Corresponding. So therefore, my third reason would be corresponding angles. Okay? Now, again, some of you might ask, why did I not use the converse? Well, I'm not proving lines parallel there. So because I'm not proving lines parallel, they gave me parallel lines, I used the regular forward theorem. Now, this is where it gets a little funky, okay? So strap in for a second. Transitive property. Oh my God. Now you'll recall from Unit 1 that transitive property basically says this. If A equals B and B equals C, then A equals C. In other words, the 2 statements share something in common, and I can cross out whatever's shared, and set the other parts equal to each other. Take a look at these 2 statements right here. Do you guys see anything that's shared? Yes, angle 1 is shared. So what I can do is cross out the angle 1s and actually set angle 3 congruent to angle 7 by the transitive property, right? Last but not least, this part right here does itself, okay? Look at this. All I have to do is write what I was trying to prove. Okay, so how did I now know? Let me actually write this in. How did I now know that A is parallel to B? What gave it away? Well, think about what type of angles these actually are. 3 and 7 are what type of angles? They're both, well, if I look at the diagram sideways, right? They're both on the left side of this transversal, and they're both above their parallel lines. So I would say that those are corresponding, but because I'm trying to prove the angle, or I'm trying to prove the lines parallel, instead of using regular theorem, I would use the converse. All right, so I would use the converse of corresponding angles. Again, guys, the biggest thing to remember when you're asked to fill in a proof involving angle types, if you're asked to make a choice between regular theorems and the converses, here's how you're going to do it. Regular theorems you use when you're proving angles congruent. For example, step 3. By contrast, converse you would only use when you're proving lines parallel. For example, step 5.